Hi everybody. Today we will continue our ESP Basic tutorial series with a new driver implementation. And for today I have chosen the PCA9685 that it's a 16 channel 12-bit PWM I2C bus LED controller. Yeah. I know that this is a quite long awaited driver example, so I will try to make it to look as simple as possible as usual. As you know already, the PCA 9685, it's an I2C compatible 16 channel LED controller. When it was designed, it was mainly designed like RGB A controller, yeah, for backlight application, but it's now widely used for different other applications. What's remarkable with this one, it's the fact that each LED output has its own 12-bit resolution fixed frequency individual PWM controller. Yeah? So that means basically 4096 steps for each LED light control. Yeah, and it has also the programmable frequency from 24 hertz up to about 1.5 megahertz. Yeah, uh, you would like to go as high as possible, especially if you design a light fixture to use, for example, in combination with a camera or something like that. I'm just saying this one because I've just finished about 2 weeks ago a design for a camera for pick and place video camera, and if your PWM frequency for your light control it's lower than 1 megahertz, it's just driving crazy the camera. So as high as possible PWM frequency means obviously less flickering and annoying things on the video camera. Yeah. Okay, so as you know already, usually these driver tutorials are split into parts. In the first part, we will talk a little bit more about the hardware side, and we will take also a look on a very basic driver implementation that will make us understanding how to work with the dedicated registers for the PCA 9685. And in the part 2 we will do let's say more elaborate, more complicated driver example. Yeah, I really think that this is the best way uh, to make things easier to understand. Okay, for the today example, we will use this extension board if you want. Yeah, so basically I have designed a while ago this PWM extension board for the next evolution board. Yeah, so you just have on it the PCA 9675, and of course the proper decoupling cap. You have the option to install the requested I2C pull-up resistors if you don't have already them installed. Yeah, it's not the case with our next evolution board because we have already on the board the resistors. Yeah, but if you use the board with another ESP8266 or Raspberry Pi or ARM or whatever, I won't repeat anymore this thing. all these things, all these boards, all these extension boards can be used with any decent MCU that has I2C uh, compatible bus available. Yeah. So on the top we have the IC itself. We have the decoupling cup. We have very nice uh, connectors for all the pins that we are interested in. So basically on the left side we have the first 8 LED connections, yeah, from P0 to P7, and on the right side we have the other 8 from P9 to P15, and obviously a ground and a VCC. Yeah. On the back of the board we have also 3 jumpers from where you can select your I2C bus address. Yeah. So with these 3 jumpers, basically you can change the I2C address for the PCA 9685. Yeah. The standard the default I2C address is 40 hexa. That means 64 decimal. Yeah. But you can change it from here to avoid the interference with other I2C bus devices that you have already, and they might be on 40 hexa. Yeah? Or, of course, you can have multiple PWM extension boards. Yeah, and you can choose one I2C address, different I2C address for each of one, and you can end up, if it's necessary, with up to 128 different PWM channels. Yeah, this is quite a big number actually. Yeah, so as you will see from these independent PWM channels, you can drive directly the LEDs. You can also hook up an external MOSFET driver for driving more powerful stuff. Uh, and of course, you can use these PWM channels to drive even the MPDM version 4 dimmer board. Yeah, if you know the AC dimmer board that you can find on my blog, can also be driven with it, with this board. Actually, I've done a test with 4 AC dimmer boards connected to the 4 PWM channels, and they were working very nice. Yeah. Okay, so this is in terms of the board and the simple setup that we will do. So basically we will use this extension board, and we will use next evolution board and a breadboard and few LEDs and few resistors and few wires. Yeah. Okay, so this is the the setup that I'm talking about. Yeah. So as you can see here, we have the ESP8266 next evolution board. Yeah. On top of it, it's connected the PCA 9685 PWM extension board. Yeah. Directly on the next bus. As you can see, it's fully compatible with the next bus. And from the first 8 connections, 8 LEDs outputs, yeah, 8 PWM channels if you want, we just hook up some LEDs with the current limiting resistors. Yeah, so this is how it's looking, the setup. It's very straightforward and very simple. I've chosen to use only the first 8 PWM channels just for the sake of the example. If you want to use also the other 8 for a total of 16, it's very simple. Just bring another breadboard and just add another 8 LEDs, and that's it. Yeah. Okay. Now let's move a little bit further, and let's see what's happening on the software side. Yeah. Okay. So for the software side, I will choose again to keep in mirror the PCA9685 datasheet on the left, and on the right we will have the web editor for ESP Basic. Yeah? This is my usual, let's say, working desktop for writing drivers. And I'm keeping also down open the serial port that I can use for debugging, and also I can see if the ESP Basic is crashing or rebooting, or what's exactly the status. And of course you can also send here uh, debug messages and other stuff. Yeah. So this is I think a quite handy setup. Just connect on the serial port with PuTTY to see the status. Open your uh, web editor uh, in your browser, and keep an eye on the datasheet, because I know that without properly reading the datasheet and having in front of your eyes, it will be very hard to be able to write the proper values in the proper registers and to make things happening as you wish. Yeah. Okay, so now in terms of the software, in terms of the driver for the PCA 9685, because we have an I2C bus compatible IC, of course the first thing that we will do, we will define our I2C bus. Yeah, so basically we need to choose our I2C bus pins. Yeah, in our case they are 4 and 5. We need to find out and identify our uh, device address. Yeah, so in our case it's 40 hexa, yeah, or 64 decimal. I will suggest you, if you have trouble with this thing, uh, first just run the scan bus. Yeah, you remember the scan bus. Yeah, so just use the scan bus program, and just give me a little bit of time to have a restart. Yeah, so after connecting the IC, I think it's a good idea to run the scan bus, and this thing can be applied to any I2C device. Yeah, so it's connected, run the scan bus. Yeah, uh, just a second, this is strange enough. uh, as I told you, this is very handy. You can see what's happening here. We just had a crash. um, okay. I think I don't have the scan bus installed. Just a second. Okay, so we have run the scan bus, and you can see the device was found at 40 hexa or 64 decimal. Yeah? After we are sure that everything is okay, then we can go back to our PCA 9685 driver, yeah, and we will put here the right device address, yeah. Of course, if you have multiples, it's even better to run the scan bus, because then you can see the address for each one, yeah. Okay. Further, we will define some values for some registers and for some default locations that we need to use in the initialization mode, and after that also for reading and writing the values for the IC, yeah. So as you can see here, we have a mode 1 and a mode 2 defined at 0 and 1, yeah. And basically what's happening, mode 1 it's 0 location in the register, and mode 2 is 1, yeah. We have also location for starting the LED registers, yeah. So basically LED 0, it's starting at 6, yeah. The value for reset is defined as 1, yeah, and the read register value it's 0. Of course, you will find all these things in the datasheet, and to understand exactly what's happening, you really need to go through the datasheet. It's impossible to understand without reading the datasheet, yeah. So as you can see, you have the control register defined, yeah, and in the control register, yes, we have exactly as I told you. You can see here 0 decimal 0 hexa, it's mode 1 is read write, yeah, mode 1 register, mode 1 register 0, yeah, mode 2 register it's 1, yeah, and it's defined there, yeah. For the LEDs 6, you can see here 6 LED 0 read write, and from here down you have all the LED registers, yeah. So basically from 6 down, yeah. So this is, if you want, 6 is the first one, yeah. Okay, this is the control register, yeah. And after that, this is quite long because you have all this LED status, yeah. In mode register 1, yeah, mode 1, that it's at the address 0 hexa chosen by the control register, yeah, you have these bytes defined here. And as you can see here, from here you are choosing a lot of things, like the type of the clock, if you want auto increment for the register, if you want to keep it in the low power mode, or you need to put it in normal mode to run it, and so on, yeah. In mode 2 register, we have other interesting stuff, and basically we will be interested about the out drive structure, yeah. So from here you will choose, with invert and out drive, you will choose the type of output that you want to have, yeah. So if you want to have uh, um, just a direct LED connection, as we are using in our example, or you can see here, yeah. So we have direct LEDs, yeah. They are just LEDs there, nothing else, yeah. Or you can have MOSFET. You are just driving a MOSFET or a transistor to drive a bigger load, yeah. I think it's here down somewhere. and we will talk about it. PWM frequency and other things, we will not go so deep, so we will just try to keep it simple, as I said. After that, when you have a basic driver working, you can start complicating things. It's no problem at all. Yeah. Okay. So these are the main register definitions that we are interested in now. Yeah. I will define also another two variables for LED on, LED off. LED and it's just allocated number for the LEDs. We will define an array as LED status. Yeah. So here we will keep the status for each LED. Yeah. So as you can see, we have 8 because we have 8 LEDs here. If you have 16, you need to have 16 here. Yeah. Okay. Now, the first thing that we need to do is to initialize the PCA 9685. Yeah. So the first thing that we will do is to reset the device. Yeah. So basically, in the register mode 1, we want to write the reset value. Yeah. So this one will tell to the IC to just reset. Yeah. So for this one, we will use the write register function or subroutine if you want, and you can see it here. Yeah. So we are just starting the I2C communication. We will write the register value, and after that we will write the data value that we want to write in the register, and I2C communication will end and we will return. Yeah. In the same way, we have a read register function that will open the communication with the device. We'll write the register value from where we will want to read the values. We will end up the I2C communication. After that, we will begin again the I2C communication, and we will do a request to the device for the number of the bytes that we want to read. Yeah. And after that, we will read the values with the I2C read functions, and the values will be read obviously from the register that we choose. Yeah. Another useful function is the write LED function. Yeah, where we will write in the corresponding LED register the value that we choose to write. Yeah. Okay, so basically you have a value for keeping it on and a value to keeping it off. Just take a deeper look in the datasheet, and obviously you will understand. Yeah. So from a point of view, let's say that for the driver you need the low-level functions. Yeah, the direct hardware access functions. So let's name these ones low-level functions. Yeah, of course you can say low-level subroutines because it's basic, but let's generally say that these are the low-level functions. Yeah. So for this driver, we need just 3 low-level functions. Yeah. Write register, read register, and write LED register. Yeah. And the other ones are high-level functions that will call these low-level functions. Yeah. This is a very simple way to keep a well-structured program, and also will help you a lot to be able to keep in your mind the structure, especially when you have more complicated drivers. Yeah. So low-level functions, three functions: write register, read register, and write LED. Yeah. All the upper level functions, high level functions will use these 3 low level functions. Yeah. Okay. So back to our story, we will just do the proper initialized of the PCA 9685. Yeah, so basically we will choose mode 0, reset. We will write to the register mode 0 the reset value. The IC itself will reset, and after that we need to check if the PCA 9685 is properly initialized. Yeah, and for doing this thing, we just calling the read register that will read from mode 1 register. Yeah, and if it will find the value 1, then we'll say that the init is okay, and if it's not 1, then it's false and we have an init failure. Yeah, okay. We can also test this thing. Yeah, so if I will press now the run button, you see we have here PCA 9685 initialize. Okay, let me go to main scene. If I just remove the, I just want to remove the extension board from the ESP and run the program again. As you can see, now we have initialized failure. Yeah, so the let's say the detection, it's working okay, and we know for sure when it's properly initialized. Yeah, okay. I will put it back. Okay, very nice and shiny. Let's go back to our drivers. So initialized subroutine, it's working okay. Yeah. Next we will just define a header and a text box where we are printing the status for the initialization. Yeah. Further down in the driver initialization, I choose to use the auto increment. Yeah, auto increment, you will see it's 160. Yeah, so you need to write this value in your register, yeah, with the write register function. So this one will enable the auto increment. Yeah. The next thing about setting the auto incrementing, it's to choose the desired output mode. Yeah, if you remember, we were talking about this thing a little bit earlier. So from here you can choose your output mode, and as you can see also in the datasheet, you can use the PCA9685 without any external drivers, and we will do it in our case. Yeah. The output drivers are 5.5 volt tolerant and can sync up to 25 milliamps. Yeah, at 5 volts. Yeah. Keep in mind that this one is not sourcing, it's syncing. Yeah, it's very important also when you are doing the wiring. Yeah. To choose this type of configuration, you need to work with your invert bit in the mode 2 register, and also with outdrive bit that it's in the same mode 2 register. Yeah, and as you can see here in the datasheet, they are looking exactly the three available configurations, yeah, that can be defined. So we are using this one, direct leg connection. Yeah, so basically from the VCC, we have a limiting resistor, an LED, and the LED connection that it's going directly to the P0 pin. Yeah, so let me show you here. Yeah, so let's choose this one. As you can see, we have the VCC going in the LED, the limiting resistor, and after that directly to the corresponding pin. Yeah, okay. This is the option that we will use today. Yeah, you have also another two options to use a P-type driver and to use an N-type driver. I'm talking about MOSFETs. Yeah, and in this case, as you can see, the values for invert and out drive are different. Yeah, okay. So our mode is direct LED connection. We'll set the output mode invert 1 out drive 0. Yeah, it's this one, invert 1 out drive 0. So the register that we will choose to work with is mode 2, because these things are in the mode 2 register. Yeah. The data it's 16. Yeah, you will take a look in the register and you will see why it's 16. And it's right with the right register low function. If you don't want to use this option, just comment it out and you can choose to use your external N-type driver or your external P-type driver. Yeah? Just change the register will remain mode 2. Obviously, the data will change to 4 hexa or 14 hexa. Yeah? For choosing the invert 0 out drive 1 like here, or invert 1 out drive 1 like here. Yeah. So that's it. With this last one, we have also choose the output mode that we are interested in, and the next things are just the interface. So we will just define a text box where we will see the active PWM channel or LED number in our case. Yeah, we have a button for setting the LED on, a button for setting the LED off. Yeah, and they are just down here. Yeah, LED on, LED off, calling the right LED low function. Yeah. Some buttons for each LEDs. I have defined also another button for a loop example, yeah, just to run a nice loop through all the 8 LEDs, and an exit button to be able to properly exit the program to the end. Yeah. For each LED, it's defined a subroutine that is called by the corresponding button, and also an LED switch subroutine, and the loop demo that will just cycle through all the LEDs. Yeah. So this is how it's looking, the basic driver. Yeah. Let's give it a try and let's see how it's working. Okay, so now we are running the basic driver example. Yeah. As you can see, the interface is defined exactly as I said before. Yeah. We have the initialization status, and we see that the PCA9685 it's initialized okay now. It's a default LED number 0, and everything is off and waiting our commands. Yeah. So if we choose LED 0, you see LED 0 now it's on. We can put it off from here, on, off, on, off. Of course, you can use here the directly the double click. Yeah, so you have LED 0, LED 1, 2, 3, 4, 5, 6, 7. Yeah, and you can see the last active LED number in the status window. Yeah, so that's it. 2, 5, 7, 1, 1, 6, 4, 3. Yeah, and of course just for fun, we have defined the loop button to see how it's going through all of them. Yeah. So if you are pressing the loop button, it will just go through them and will change the status. If I choose to create some sort of pattern and I will press the loop button, it will invert the values, the status values. Yeah. So basically, it's just inverting the status. Yeah. So this is how it's working. Our very simple PCA 9685 driver. Next time we will go obviously a little bit deeper, and we will also talk about the individual PWM channels and how to use them and how to work with, and how to make it running very smooth. That's all for today. Uh, I want to thank you for watching, and if you like my work, please subscribe and please give me a big thumbs up. Thank you very much, and see you next time.